Hey guys, welcome to yet another Swift deep dive. And in this deep dive, we're going to talk about structures. Now, structures helps us create custom data types. So whereas previously we saw that there were loads of basic data types that comes pre-built along with Swift, for example, strings, ints, floats, doubles, booleans, arrays, and dictionaries, you name it. There's a whole lot of different pre-built data types. But what if we needed our own data type, something that groups together related properties and behaviors? For example, our quiz questions. Currently, we have a 2D array, which basically forces these two pieces of data, the answer and the question, to be associated with each other. But actually, these are two properties of a question, right? The text of the actual question, as well as the correct answer of a question. Those should really somehow be interlinked together. And in order to do that, we could use a structure. So we create a structure by using the struct keyword, and then we give it a name. Now, notice how the names of structs are a little bit different compared to methods or properties. When you're creating a struct, the name that you give it has to be capitalized even at the beginning. So that way you can tell that it's actually a data type. Similar to how our string, int, or float data types all start with a capital letter. Let's go ahead and create our own structure in Playgrounds. So let's say that I was to create the structure of a town. Well, I would start by writing the struct keyword, and then I would give my structure a name. So let's just call it town. And then I'm going to open a set of curly braces inside of which I can define the properties of my town. So what are the kind of properties that a town might have? Well, it might have a name, right? So let's create a constant using the let keyword and give this constant a name of name. So the name of the town. And then I'm going to give it a value. So let's call it Angela Land. Now let's think, what are some other properties that a town might have? Well, it probably has some citizens, right? But in this case, I'm going to create a variable. And the variable is going to be called citizens, and it's going to be equal to an array. So these are all the people that live in Angela Land. And it will be myself and let's say Jack Bauer, my ultimate hero. And so now that we've got the citizens who live in the town, the name of the town, the last property I'll add are the resources in this town. So let's say that we had some grain, maybe 100 bags of grain, some ore. I think I've been playing a little bit too much of Settlers of Catan recently. This is all I can think about. Let's say we had 42 blocks of ore. I'm not sure what's the unit of count of ore. And then let's say we had some wool. Notice how here I'm creating a dictionary. So it's a variable called resources, which is a collection of dictionary items. So we've got our key and our value. So 100 bags of grain, 42 bags of ore, 75 bags of wool. And these three properties are now all packaged together into my town structure. Now that we've created our struct, it's time to actually initialize it. By initializing, I mean creating an actual object that we can use. So to create an actual town from our town structure, all that we would need to do is create a new var, and this var will be called my town. Now, this my town is going to be the actual town created from this structure. And to express that in code, we would write var my town equals town and then a set of parentheses. So now what I've done is I've created a new copy of this town structure, and it's held within the variable of my town. So that means I can actually use this object my town, and I could access the properties of my town. For example, I could print my town, and to access the properties, I would use the dot notation. So as soon as I write dot, you can see all the things I can tap into. And let's say that I wanted to print who are the people who live in my town. I'm going to print my town.citizens. And currently it's just me and Jack Bauer. Now I can tap into some of the other properties as well. So for example, if I wanted to use my string interpolation to get hold of my town dot name, so the name property of my town, and then let's say my town has, let's do like a little report, shall we? How many bags of grain have I got? So then it would be my town dot resources, and then we would use the square brackets to access the grain key. And then we could say, well, it has this many bags of grain. So now if I run my code, you can see that these are the citizens, and Angela Land has 100 bags of grain. That's a pretty good town, if I might say so myself. Now with the object that we've created, my town, we don't have to limit ourselves to just retrieving data or retrieving the values of properties of this object, but we can also add and modify it. So for example, if let's say that my town has a new citizen, let's say that Keanu Reeves decided to move into this wonderful town, well then I might say my town.citizens, so it access the citizen property of my town. Well, then I can append, so add something to my citizens array. And the name that I'm going to append is, of course, our new neighbor, Keanu Reeves. So there's 3 of us now in our town. And I can print, for example, my town.citizens.count. And when I do that, you can see that after I've added Keanu Reeves to the citizens of my town, we now have 3 people living there. Whereas previously, when I printed my town.citizens, we only had 2 people. Now, so far, the structure of our town only defines the properties of a town. So towns should have names, towns should have citizens, and they should have resources. But we can also define a behavior of our structure. So we can make towns be able to do things like build barricades and, get everybody inside, and we sort of eat all our 100 bags of grain. And to do that, we would simply just create a function within our structure. So let's say we created a function called fortify. And now inside this fortify function, we could simply just, for ease of use, we'll just print defenses increased. So now our town structure has properties and it has something that it can do. Now, when we have a function that's associated with a structure, well then the name for it is actually called a method. So if you hear the words functions or methods when people refer to it on Stack Overflow or online, just know that they're both referring to this same thing, the thing that we create with a func keyword, and it defines some behavior inside the curly braces. But if this behavior was defined inside the curly braces of a structure or a class, then we would call it a method. But if it was sort of standalone, free floating around somewhere, well then we would call it a function. At the end of the day, it's just defining behavior, something that it can do. But now I can trigger this method or this functionality that my town has by writing my town, so this is the actual object that can do things and has properties, dot, and I'm going to make it do something. Now notice here that this M stands for method, and if I hit enter, then my town is going to fortify itself when I run that line of code. And we can see that my town has its defenses increased, so it's able to perform an action or a behavior. When we create a struct in our code, we're essentially creating a blueprint for an eventual object that will get created from our blueprint. And in this blueprint, we get to plan ahead for how this eventual object will be. For example, we create variables, and when our variables live inside a struct, that variable is associated with our struct, and it's known as a property of that struct. Similarly, we've created functions inside our structs, and when functions are created inside a struct, they're known as a method. So you can consider these properties as a way of defining what this eventual object created from the struct will be like. So its attributes or its properties. And the methods can be thought of as what the object can do. So in the context of an actual car object that gets created from a car struct or car blueprint, well, those properties might be things like the color of the car, or the number of seats it has, or the number of doors it has, or whether if it's a hatchback or a sedan, something that describes what this eventual object is going to be like. And the methods for the car, well, those are things that the car object can do. So things like drive, or brake, or switch on the indicator lights. And it's through describing these properties and methods of the objects that will get created when our app is running. So these objects are invisible. We can't see them, we can't touch them, but we can plan for how they will behave and how they will look by creating these properties and methods. So when we were defining our town struct, we were writing the blueprint for the eventual object that will get created. And we can take our blueprint and initialize it, which turns it into the actual object, in this case, maybe an actual car. But what do I mean by that? What does initializing mean? And what does the code actually look like? Just like we would create a function, we create our initializer in a pretty similar way. We have our parentheses for the inputs that gets passed over. We have our curly braces for the implementation or the code for how to initialize our structure. So how does the initializer get used? Well, the initializer gets triggered when we create our object from our blueprint. But why do we have initializers in the first place? What's the purpose of the initializer? Well, suppose you want to create the next Civilization or Settlers of Catan video game. Well, in that case, you're going to need more than one town, right? Well, in addition to Angela Land, you'll need Athens, Beijing, and New Delhi, and many, many more. But all of these places are different. They have a different name, different citizens, and different resources. Wouldn't it be nice if we could use our struct to act as a blueprint for all of these towns, but still be able to customize each town? Well, that's where the initializer comes in. Let's head back into Playgrounds to see this in action. Let's delete everything we have here currently and just be left with our structure. Now, I'm also going to delete the values of these properties to keep my town very generic. So the name is going to be a string data type. The citizens are going to be an array of strings, and the resources are going to be a dictionary made up of strings for keys and integers for values. So now my town structure has blank properties for each of these attributes, and I can now define a custom property every time I create a new town. But before we do that, we need to create the initializer. So I'm just going to write init, and when my Swift code snippet symbol comes up, I'm just going to hit enter. And inside the placeholder, which says parameters, I'm going to add some input parameters. So when I initialize a new town from my town structure, I'll be able to use these inputs to fill in my properties. The first one is going to be town name, which is going to be of type string. Next, it's going to be the people of the town, which are going to be an array of strings. And finally, I've got the stats for my town, which is going to be a dictionary comprised of string keys and integer values. So that's all three inputs that I need for my initializer. And inside the initializer, what I'm going to do is I'm going to set my town's name property to equal whatever got passed in as the town name. And then I'm going to set my citizens property to equal whatever got passed in as the people of the town. And finally, my resources property is going to be populated with the stats that have been inputted for this town. So now, if we're creating our town with an initializer, the way that we would do that is let's create a variable called, I don't know, another town. And let's set it to equal a town created with our town blueprint. And then once we open a set of parentheses, you can see all of those input parameters show up: town name, people, and stats. So if we hit enter, we can use these placeholders, and you can hit tab to go between them. And we need to provide some values in each of these positions. And we can also see what type of data we need to provide. So the first one for the town name has to be a string. So let's call this nameless island. And the people who live in this nameless island will just be one guy, and it's going to be Tom Hanks. And for the stats of this town that I'm creating, it's just going to have a whole lot of coconuts. And let's say it's got 100 coconuts on this nameless island. So now that I've created another town, I can do exactly as what I've done before. I can tap into my object, the another town. So remember, the object is the thing that's actually created from the blueprint. And I can, of course, print the properties, say the citizens or the name. I can call or trigger the methods or the behaviors that the town can do, namely fortify itself. But I can also, of course, tap into, let's say, our citizens. And then, just as we did before, we can append a new element, which happens in this case to be a beach ball who's going to join the citizens of Nameless Island. And he's going to be called Wilson. So now we have another town, which is an object created from the town blueprint with all of these properties that we've specified when we created the town using the blueprint. And we're able to use this object just as we did before to tap into its properties or to manipulate or change some of those properties. And we can, again, if we wanted to, now print our another town, so our object's property. Let's print and see who lives in this town. So this time it prints there's Tom Hanks and there's Wilson on Nameless Island. Now notice how I'm twisting these names so that they don't overlap with the names I've got as the properties of my town. Because in reality, it would be much easier for me to just name this name this citizens, and name this resources. But now, when I initialize it, I have to set the name equal to name and the citizens equal to the citizens and the resources equal to the resources. Now, it kind of makes sense if you really think about it. So I'm saying that the name property of my town structure should be set to equal the name that got passed in as the input parameter. But this code is very confusing because this name matches exactly this name. Now, what else can I do? Well, I can make it really explicit which one I'm talking about, whether if it's the property or whether if it's the input here, by simply adding the word self in front. Now, you might have already come across this keyword self, and we haven't really gotten around to explaining it. And this is the perfect time to really explain it, because the self keyword refers to the eventual object that will be created from this structure blueprint. Whereas right now we're saying self.name referring to the property name of our structure town. Well, eventually when we try to initialize our town, that self is going to refer to the object that's initialized. So for example, the another town. By adding that self keyword in front of all of these properties, I can now easily differentiate them by saying, well, self.name, of course, refers to my town's name property. Self.citizens, of course, refers to my town's citizens. And you can view this self keyword as referring to the structure. Now that I've changed the parameter names of my initializer for my town structure, well, I also have to change them here, right? So this is what this error is about. It says that the labels should be the name, citizen, resources, but instead we have town name, people, and stats. So we can go ahead and click fix for it to change it for us to the ones that we specified in the initializer, and all the errors go away. But from now on, also, when we create, say, let's create a ghost town from our town blueprint, and when I hit enter, you'll see that these are now the parameter names I have to provide. Let's create our ghost town, which is going to be called Ghosty McGhostface. And the citizens are none. There's nobody living here because it's a ghost town. And the resources are, it's just got like a lot of tumbleweed of 1. It's just tumbling around in our ghost town. So notice how right now I've got one object created from my town blueprint, which is called another town. And in there, we've got Tom Hanks with a bunch of coconuts. And we've got another town called Ghost Town, which again, we've created from exactly the same blueprint. But this town's completely different. It's got a different name, it's got no citizens, and it's got just a single tumbleweed. So now when we tap into our objects, let's say that in another town, we've got a new citizen who's moved in. So we'll append Wilson to that town. Whereas in the ghost town, well, nothing really happens, but let's say that we just decided to fortify the town. Notice how here I'm tapping into different objects that have essentially been created from the same blueprint. And when I hold down Option click on each of these objects, you can see that they both have the same data type. They're both created from the town structure. But they are really different from each other. They have different names, different citizens, different resources, and I can specify which one I want to manipulate, which one I want to change, whose properties I want to tap into. And now we've got essentially a whole bunch of things that we can play with by using this blueprint as a starting point. So now that you've learned all about structures, it's time to test your knowledge in the structures assignment on Replit. So head over there before you continue in the project. And once you're back, I'll see you on the next lesson.